So there's a new case here where we can mix lifting and spinning components and show how they can complement each other. This is based over sea at the moment, but I guess this could be installed on land. I'd prefer the sea case in this. So you have an arrayable mesh on the ground area on the surface, and over that mesh you've got these lifting structures. This sort of catenary front line that's pointing into the wind. Let's move the wind about a wee bit. So these are kind of like the net structures, and on this you've got a float here which is able on a cart to go around this stretched outer. You see you've got this sort of inner tensed curve pulled out to this tensed hex net. So on that, this would be cart connected there, round the back, and you'd have a couple of tie-offs on the front. And on these nets, you could have, say, an arch kite along the front edge, arch there to there, arch from that node to that node, arch from that node to that node, and being a full arch set mounted on that arch, you could also do it across the back, you could do it across the insides of these. You could keep that form very tense and always weathercocking. The other advantage of this form is that you've got these lines here. These can be swivel detached from the net, but still forming part of the net in tension, and have rotors mounted on them of various configurations. So you can run that down there, a line of rotors there, line of rotors there, line of rotors there, line of rotors there, and out this way. Thereby, from two small poles like that, sorry for jumping about so much, yeah, from two small poles you could end up with, say, 50 or more rotors there. So yeah, that could end up being way more rotors if you start filling it densely that way. There's a lot of scope, I reckon, for that. I'll get finishing off the drawing.